always can meet anytime during the semester, and we can do more about the G-coding. Briefly, again, to discuss what we've done earlier. So I'm going to have the Excel sheet where we have everything on it. That's mainly for the part that's, once again, is going to be part of the assignment number 1 and the advanced manufacturing. Where's that? Yeah. Okay, so this was the original shape. We had this shape, and in the middle we have hexagonal shape and C slot with the circular pocket in the middle. And it does have 6 holes. What you are going to need to do is to write down the code to remove the material from the top and generate the hexagonal shape and making the 6 holes, and later to make the disc shape at the end. Because basically what we're going to start working with is going to be a square shape, something similar to this photo. We're going to start with a block and removing the material until we're going to have the final shape. Sorry, this is not for you. Okay, and to do that, we need to analyze the shape. This shape has the diameter is variable, and the variation is going to depend on 2 factors. As you can see here, we have the A, and we have.
Sorry to interrupt. We can't see your screen.
Oh, really? But it's can show that. Okay, again to reshare the screen again, because it's showing that showing the screen. I'm going to stop that and reshare it again. Okay, is it shared now?
Perfect.
Now we can see it, sorry?
Yep, perfect.
Okay, so actually earlier when I told you that the annex is available here, I was showing the screen or not?
For the NX, we can't see it, but for
the
Excel file,
for this one is a black. Yeah,
maybe once you load it up, I think once you load it up, it should be okay.
Yeah, I think that Solomon asked me to told me to reinstall it again and untick something. Okay, I will do that later. Anyway, now that's the engineering drawing we have. This will be the most important thing now. What we need to write down was making the code to cut the material around this hexagonal shape to these dimensions, and then we're going to cut the it's 270-degree actually C slot and the pocket in the middle. The dimension of this part actually are going to be variable according to your student number. We have the term A and the term B, which are the 2 digits we have selected from the student number ID, and thus the dimension is going to be quite different. I think that the only fixed thing here was the diameter of the hole, which is 12 millimeter. And this will give you a hint that the diameter of the cutting tool we're going to use is going to be 12 millimeter diameter. So we started to analyze the thing. As you know, that for hexagonal shape, the rule we have is that I will bring this line. Okay, the distance from one edge to the other is equal 2 times the side. This will give you a hint that you can find what will be the length of this line, which is going to be the same as this line. Okay, as you can see, actually is the equal size triangle. Okay, and also this will give you that this angle is going to be equal to 180 divided by 3, which is 60 degree. This will help you a lot to find the location of the intersection point for the lines. Now we start to find the lines, which are going to be the tool path. The tool path, once again, we said there's going to be the line that the center of the cutting tool will follow to perform the cutting by using the side of the cutting tool. And that's what we call the profile cutting. So we start to offset at the beginning by 6 millimeter from all the corners. Okay, and we sketch the line. Now we choose to have the datum point in the middle. Selecting of the datum point will depend on the following things. First, in general, the datum point should be at this point, in this corner, at the bottom left corner. Why using that? Usually the vice is not going to be here. It's going to be on these sides. It's always going to be to the left and the right. Okay, so I just try to explain to you why we have the datum point at this place. Okay, so that will be the device. One of the sides of the device, which is usually going to be from the top, it's going to be the right one, is going to be the moving part. The moving jaw is going to go forward and backward, where you can put the part in the middle to hold it. This one is going to be fixed. So if I'm going to decide that this corner, which is actually going to be like that, because the device is not going to be that small, above this side of the jaw of the device is going to be the datum point, where this x is going to be 0, y is going to be 0, and the height is going to be 0. Usually we choose it a little bit above the work part, at the top of the work surface, or the highest point is going to be actually the highest surface we have for the finished part. Now, in this example, we use the, well, actually everything has been shifted, so I need to go back again. Yep. We choose that to have the datum point in the middle. This will make it much easier for us to find out the location of the points, because in the symmetrical shape or the semi-symmetrical shape, if I'm going to find the points in one quarter, I can find it on the other 3 quarters. The only thing is going to be the coordination here, the same as the coordination here, but the sign here is going to be different. Take a look to this cross. This corner, we are going to have the x and the y value are going to be positive. At this square, we are going to have the x negative, but the y positive. At this square, we are going to have the x and the y negative value. And finally here, we are going to have the x positive, but the y is going to be negative. So once again, just finding this side, and then you can distribute on the other sides, just change the signals. So we choose the center to be the datum point. Again, we to make the tool path attached to the final cut, we offset by the value which is equal to the radius of the cutting tool. And of course, this is only going to cut around the shape. But we still have a cubic shape, and we need to remove the material starting from the outside to the inside to have the final shape. So we may have multiple offsets until we are going to have the final one. We're always going to start once again from the outside, going to the inside, and this is simply going to be because we would like to have, the cutting tool to be cutting from the side only, and this is simply going to reduce the forces we have on the cutting tool. If I'm going to insert the cutting tool inside the work and start to move it, it's going to have resistance from all the direction, and this is going to add an extra load on the work part. Just to tell you about that, that's something you need to think about it from now on as an engineers. Well, actually, it should be for the human, but as engineers, what we have is that always think about everything around you in a green way, or the ego way, or the eco, whatever you're going to call it, the same thing. Now, even for the manufacturing, what we're trying to do right now is, from now on, we need to think about design for X. Whatever you're going to do in the future, think about design for X. Design for X is design for manufacturing, design for the assembly, design for the environment, design for the recycling, design for example, the life cycle assessment. So just everything you think about, just put in your mind when you do design for something. Design for manufacturing is how you're going to use the manufacturing process which is available for you first, But second is going to be, which is going to be more ecological method. That's mean we don't need to consume a lot of energy when you do the manufacturing process. We don't want to have a lot of waste when you do the manufacturing process. So if I would like to cut the circle to be, for example, 190 degree, I don't want to have a block which is going to have the size to be 220, because this will mean I'm going to move something about 15 millimeter from the side to get the diameter. So simply I can take it to 195. I can cut the sides of the block here to be 195. One of the reasons that we need to remove a layer of 1 millimeter from the top, because this part has been cut by using the saw, and usually again to have this surface, and we need to remove a layer from the material. So if the final thickness of your part is going to be, let's say 20 millimeter, cut the part to 22. So you're only going to remove 1 millimeter from the above and the below to get the final thickness for your work part. That's again to save you energy for the machining, and also is going to save you the time for the machining, and it's going to save you some waste of the material. Okay, so we did that, and we are going to start to cut the work. The challenge you are going to have for your assignment is that the height of the part, the highest level here, will be varying according to your student number. So it can be anything from 5 millimeters up to 14 millimeters. So this height will be changed between 5 millimeter as basic to 40 millimeter as maximum. Just remember that when we get to remove the material in any operation, we cannot set the cutting tool to the maximum depth and start to remove the material, because this will be a lot of energy. So we're always going to start to do it by steps: layer 1, layer 2, and layer 3. We have something called the finish cut, which is going to be a debug cut. And we have finally the finish cut, which is going to give you the good surface finishing. And this will going to be something about maximum 1 to 2 millimeters, depending on the material. Okay, so with schedule lines, we found the points, and then simply we're going to connect that by using the G code, G00 to above that point at the height of, let's say, 5 millimeter in the Z. Then you go to the G01 to the Z equal to -4. Then G01, G01, then you're going to follow the links all in G01, come back to the same point, then G01 to the inside offset, and repeat the same process. Okay, G01, and repeat the same process. Okay, now we are attached to it, but we take it to -4 millimeter. We need to remove, for example, if it's going to be 5 for the height, we're going to go up once again to the Z equal to 5. Then we fly to this one, G00. Then we go down and start to repeat the same process, but the Z in that case is going to be equal to -5. And thus we're going to clear everything around the hexagonal shape. Then we go up to G00 to the height of 5 millimeters. We're going to come to above that point. Then we go to the G01 to the Z, which is equal to the depth of that slot. Then we are going to make the G03 to this point, then G03 to that point, because we said that the G03 or G02 cannot cut more than 180 degrees perfectly. So it's better to do it by steps. To cut it into half, we're going to move it to here, 135 degree, then another 135 degree, then we finish with the work. Then we go G00 to the height of Z equal to 5, travel to the G00 Z equal X0, Y0, and Z equal to 5. Then you go to the G01 to the depth of the slot. We are going to be in the middle. Then we turn to the side where the center of my cutting tool will be on this circle. Okay. Then we're going to make a 180-degree cut, another 180-degree cut to cut a circle shape, which is going to be the pocket here. And when we are going to finish cleaning this one, we need to drill the holes. The holes are going to be point to point. That's mean G00 above that point, G01 to the maximum depth, G0 0 to the Z equal to 5. Then we travel to next point, next point, next point, next point, next point. So we do the drilling, we go up, travel to the next one, do the drilling, and go up until we are going to finish all the holes. Now, this was the setup number 1. I'm going to explain this one later because this is something you need to describe in your report, which what we call the process planning. What will be the sequence of the work? Usually, the sequence of the work is going to be by set up the part, which the way you are going to hold it. And the first process we use the vise because the part has a square shape like this one. Okay, so we hold from the side. We're working on the top. Then we need to do the cut around here. So because we are going to have the holes, so we are going to put on table using the T nuts, the T nuts, which is going to be sliding in the T slots we have on the table of the CNC. And we're going to have at least 2 to 3 bolts, which is going to be fixed, for example, here, here, and here to fix the work part on the table. We put a layer of protective plywood, for example, beneath it to protect the table. Then we start to do the cutting around. You don't have to show me all the code for cutting the material to make it a circular shape. You only need to show me the code to remove 1 millimeter diameter from the side. And this will be very simple because we come to here, we go to the minimum depth, which is Z. For example, if the height of the work part is 20, you go to the Z minus 20, then you do G02 to here, then G02 to here, and then G00 to the Z equal to 5. Then you go to the whatever the point is, antenna of the machine. This will be the setup number 2. Or this can be setup number 2. You can have 2 other setup. The one in the middle, which is take the part when you finish the cutting of the top, take the part and put it on the inspection table and take a look on it. Take some dimensioning to be sure that the dimensions you had are correct. Check the quality of the surface before you're going to take it to the setup number 3, which is holding the part by using the bolts and the T nuts on the table and do the profile finishing cut at the end. Then the setup number 4 is take the part once again to the inspection table and check the dimension and the quality before you're going to pass it. That's what we learned with the G code. The G codes we learned were, in general, I'm going to insert that by making a text box. Where is that? Yep. So the codes we learned were mainly the G00. That's G00. Of course, you need to follow that with the value of the X, the Y, and the Z. Now, what will be the function of the G00 is going to be just straight line without doing any cut. Maybe I need to make it as a line without arrow to be more clear. So this will be the function of the G00. I'm going to make this one thick so you can see it. Okay, so just move from one point to another without doing any work. The other code we have, G01, and once again, this should be followed by the X, Y, Z, both for the point you want to go to. You want to send the center of the cutting tool to. Now, this function will going to make a cut. in straight line from one point to another. That's why I had an arrow. So it's usually preferred that you are going to add an F after that, which is going to represent the feed rate. I'm sorry. The feed rate was going to be what is the linear velocity you are going to have for the cutting tool. In the case of the milling, and the case of the turning, you are going to put how many millimeter per revolution you would like to move the cutting tool during the cutting operation. Now, the other two codes are going to be the G02. Again, we are going to put the X and the Y. Usually the Z is going to be fixed unless if you're going to cut it as a contour shape in the XZ plane or the YZ plane. The G02 should be followed by the R, I, and J. Okay. Now, this is simply going to cut an arc. I hate the most thing I hate in my life is sketching an arc with the axle. I don't know why. Maybe some people like it, but I think that's something they miss with the Excel. The Excel is very nice software, has almost everything, but it's missing that point. How to make a perfect circle or a perfect arc. Okay, so the arrow is going to be on the end. Oh yeah, but still small. Okay, the arrows, more arrows. It's going to show up here. Okay, let's do again arrow. And on this one. This one, I try to make it just larger, the largest. Okay, anyway, it's going to be turning the cutting tool in a clockwise direction. The G02 on the other side, G03 on the other side is going to make it in the counterclock direction. Now, we're going to talk about the radius value. Oops. G02 and G03. G03 is going to be for the counterclockwise. Okay, so don't remember that we can do it. We are going to do it the other way. Okay, and this one is going to be in the counterclockwise direction. Okay, G01, G02, and G03 are doing the cutting. G00 just doing the movement, and all the other codes we have are miscellaneous. Like we have the G17, we have the G18, G19. G17 is to cut in the XY plane. G18 to cut to the XZ plane, and the G19 is to cut in the YZ plane. We have the G20 and G21. G20 is to cut in the inches, and the G21 to cut in the SI units. We have the other things for the offset and well, we have many things. Now, one of the things we need to remember is the cutting of the radius when we are going to do the cut. If I'm going to cut around this circle, the black one, okay, I'm going to make the radius value of the movement of the cutting tool is larger by the radius of the cutting tool. If this, for example, if this radius here is going to be 100, the cutting tool I'm using is 20 millimeter. So the radius of the blue line is going to be 110. If I get to cut from inside, in some of the cases, if I get to cut from inside, then the radius is going to be minus the radius of the cutting tool. Okay, that's what we covered, and we are going to come back to this one for the students who are doing the advanced manufacturing, but I think that most of the students are aware on how to do this one. Now, let's check, make a short survey for the student we have here about what's your confident level that you can write down a code at this stage. Just type it. My confident level is anything from rate it from 1 to 10. 8, 9, and 8. Okay, now 8 is very good. 9 is perfect. We don't have actually someone say 10 to 10 because nobody can say it's 10 to 10, even for the expert people. You remember that also we covered the case of the turning operation. Turning operation last week, what we had was last week actually, is quite simple, but the problem we have is that it's tricky. One of the things I'm going to show you today before we're going to go for the CAD/CAM on the second half of this session is how we are going to use the SolidWorks to find the points when you do the writing of the G code. Just remember something that I'm going to do it for the turning operation. Just remember something that we cannot always have the CAD/CAM software, but it's very easy to find something like the free CAD software, right? So once again, if you are going to have an urgent situation to cut apart and you don't have the package, then simply just do it by handwriting. So let's start with that first. I'm going to show you how to cut the chest part by finding the coordination using the SolidWorks. So I'm going to start a new part. Now just confirm to me that you can see the SolidWorks because you couldn't find the, you couldn't see the workspace. The SolidWorks is okay? Do you see the SolidWorks here? Or I need to reshare the screen again?
Yeah, perfect.
Okay, so we are going to have a part now. Solomon and Lisa asked why they don't have the solid cam. Just to remind the student about that, we go to the ends, and then we are going to take the solid cam to make it show up. I turned off everything else because I don't need them now. Maybe I'm going to put them back later. This just to make the thing more faster, make the solid work much faster. Okay, so we are going to see this part. I don't need the solid cam now. I'm going to use it later. So we start to do a sketch, and we're going to use now. Actually, I'm going to do the turning. So I'm going to use the Z-axis plane. So this will be the top one. The X will go in this direction, the Z in that direction. So I need to do it that way, this way. Okay. Now we need to remember something. Most of the time in the turning operation, we're using the part to be cylindrical shape. So let me sketch a cylindrical shape. Do it that way. Oh, I should do it the other way. Anyway, the cross section of the cylindrical shape is going to be a rectangular shape, which is going to look something like that. This is half of it. And of course, it's going to be the same thing on the other side. So this is the top of the half cross section of the cylindrical shape. I'm going to show you once again if this is going to be cylindrical shape. I'm going to choose, for example, that the length is going to be, let's say, 100. And the diameter is going to be 40, so I'm going to choose 20 for the radius. Okay. That point is going to be the datum point. So everything behind is going to be zero, negative, sorry. Everything on the right is going to be positive, and this will be the x value. The x value, we're always going to deal with diameters, not radiuses, unless we're going to set up the machine to do something else. Now, just to remind you that this meant to be a cylindrical shape. So if I'm going to take it back to a cylindrical shape, I will, and on this line, I need this line. Okay, so it's cylindrical shape as a startup shape, and we're going to remove the material from that shape to have the chest part on it. Okay, so once again, the cross section is going to be a square shape. The cross section of the, well, once again, let me show you that. The cross section. Yeah, you can see that the cross section is going to be a rectangular shape, and that's what we're going to work in. To make it much easier, I'm going to work on the top half only. We're just going to go back to the actual, sorry, we'll go back to the actual part we sketch at the beginning. Just remember that this will be my datum point here. The z equal to 0 and the x is equal to 0. As I'm going to go up to that point, which actually I'm using this parameter to find here, you can see that the x is 20. But when I'm going to write down the coding, I'll write down the x here is equal to 40, because the diameter at this height is going to be equal to 40. I will show you later in a separate video again to post how to identify that this will be the datum point, or he is going to be the datum point, or he's going to be the datum point. Usually the machine know that the datum point is going to be the center of the tool post. The tool post, if you remember the small turning we have on the lab, you remember that it was something that we turn by hand to the inside and the outside, to the left and the right. That's what we call the tool post. If I'm going to take a look to the center of this tool post, this is what the machine in general known as its datum point. So we usually write down the X51, for example. I think it's X51. Then you will set that, sorry, the G51. Then you write down that the X is going to be offset from this point by this value for the X, this one value for the Z, where is going to be this location. And then all the points are going to be referenced to that location. Now I'm going to start work on this part. And I'm going to sketch something to be like the chest part. First, I don't know why these lines are here. I'm going to remove them. Okay, the chest part I'm going to make is quite simple. It's going to have less diameter than this one, a square shape at the top, a curved shape here, then another curve to the outside, then a base at the end. So I will start first with the base, and let's say that the base is going to be at, I will choose here, total we choose 100. So let's say that we're going to hold the part with from the end by 20 millimeters. So I'm going to have here 25 millimeters. Okay. I will make it rough because just for the simplicity. Okay, so this will be the first thing. This part will remain a cylindrical part because we're going to hold the whole thing in the chuck in this area. Now the rest is going to be made once again to be a curve here. Okay, another curve here, and then we're going to have a square shape. I'm going to make that here. I will take this height, for example, to 18. I know I'm using an old method, but because I'm lazy to do many complicated thing at this stage. Okay, so it's going to be 18 and 8. Okay, and again, here I set that again to have square shape. So let's at the beginning try to make something that's going to be straight, because this will be much easier for cutting. Okay, so again to make it as 4. Okay, and let's make the curve right here. Okay, I'm going to make a curve right here. So I'm going to make a line. I'll take it to 12, or let's make it 15. It's going to be much better. Okay. I'll put this line now. Most of these lines are going to be removed later. Okay. Now, let's try to sketch something from here to here. So let's take that to the middle. Can choose any random shape and try to make an arc. So I'm not starting with dimensions. I just try to do it, as I told you, randomly. Okay. I'm going to remove the unnecessary parts. Okay. And then I'm going to make a curve from here to here. What the length is. So make construction line. It's going to be from here to here. Then from the middle of this construction line, I will go up to random height. Let's start to, now once again, because I don't have anything in my mind now right now, just writing something instantaneously. Okay, so we got that shape now. And I'm going to remove the unwanted material. I'm going to remove this line because it's multiple lines instead of one, and make a new one instead. Okay. Now, if I'm going to revolve this one, okay, for this area, it will look like a simple chest part. I don't know if you like it or not, but it does look like a chest part. Yeah. So I'm going to work on this one just to show you how to find the points as we do the cutting for this chest part. Obviously, what's happened is that in the turning operation, we cannot bring the cutting tool and move it directly to this location, to this movement, because the depth is going to be too high, especially in this area. Is someone writing down a note? No. Okay. So what we're going to work on is we're going to cut that layer by layer by layer until we're going to have this final shape. We can see that we have multiple straight lines, and then we're going to have the final cut to be a curve shape. And that's what we're going to create now by using the SolidWorks, just to identify the X and Z location during the movement of the cutting tool. Okay, so we get close to that, and I'm going to edit the sketch. And I'm going to use this area here, which is going to give me the X, the Z, and the Y value each time I'm going to move my cutting tool. So if I'm going to choose a point here, this will be the value for the X, for the Y, and for the Z. The Y is not going to be changed because we're always going to move in the X and the Z. Just remember that every reading you are going to have for the X, you have to multiply it by 2. So I'm going to do the following operation. My first movement is going to be, let's do that by construction line. I'm going to get the cutting tool from anywhere to this space. Okay, and I'm going to put it in this location. Now, you can see that this location is the X is equal to 20 and the Z is equal to 1.35. We can simply make the Z is equal to, let's say, by the way, this should be positive, not negative, away from what we have here. Take it to 2. Okay. Now my cutting tool is in this position, and I will start to do the first thing is remove a layer from the face. Again, because when we prepare the part, the top surface is not going to have a good surface finishing. So we do a process which is called the facing. In the facing, I will bring my cutting tool to the end here and then send it toward the center. Then we go and leave it. So my first movement from here is go from here to here, then going to the center, then we go out and come back to here again. Well, I should make all these lines for construction. I just missed that. Because I would like to tell you that these lines or the construction line is going to be the tool. I can do it here while I'm looking on the other side. Okay, construction line. Construction line. Construction line. Okay, so the first operation was the face milling. We don't need to know what the coordination here. You need the X1, Z1 form here, X2, Z2, X3, Z3, which is of course 0, 0, X4, Z4, X5, Z5. So now, do you understand what I've done right now? I'm going to show you that on my own screen instead of, is that good? Yeah. So if you can take a look to my screen, that's what I've done. That's my cutting tool is rotating. Let's say something like that. Okay, so I brought the cutting tool to here first. Then I went to be in touch with it to the certain depth. Then I go to the center. I just removed a layer. So whatever the thing is going to be, this will be decided by the Z value I'm going to send. For example, I'm going to send it to Z equal to -1. Then I'm going to remove 1 millimeter from the face, then continue doing the work. Okay, so now what I'm going to do is I'm going to remove the material from the outside diameter until I'm going to have a shape similar to this one. Just remember that what I'm going to do is going to be repeated multiple times, and this will get to make it quite confused for the first time. So now I'm at this position again. I will go to this position, which is going to be, for example, 1 millimeter depth, or let's make it 2 millimeter directly, 2 millimeter. This will be the point number 6. Then I'm going to send my cutting tool all the way to here. So I'm going to send it to the Z equal to -58. Then I go up to the Z equal to 4. And I will go back to the end. I don't need to come back this one. So I will come back to here. Then I will go down to that level, cut another layer of this part. I'm going to travel back to the same height, going back to the beginning. Okay, go insert down the cutting tool to inside the work part. Go back to this end, go back to that level. So we keep doing that. It's something like we doing the waving of the work. Down, to cut. Now I know this should be something boring, but at the end you will find it's not going to be that hard, especially when you are going to use the SolidWorks to do that. Actually doing the thing by hand is going to be too complicated. And before 3 years ago, I was asking actually the student at Washington Uni to use the paper and the pencil to find all the coordination points. But now I start to be nice with them and allow them to use the SolidWorks to find the points for the easy manner.
Can the cutting tool only cut one way?
Yes, because what we have in the cutting tool and the turning operation is either left-handed or right-handed. That means either going to be able to cut from left to right or right to left.
Yeah, that makes sense.
Yep. Okay, so this will be the multiple steps we're going to cut. We're going to have something like a spherical shape. And the rest of the material is going to be removed by using the last cut, which is going to be the G02. So now to explain the process once again, we come to here, G00, G01, G01, G00, G00. Or I can come to here directly. Then G01 to that point. G00, G00 to here, then G01, G01 to the end. We go up G00 and keep cutting these steps one after the other. We're going to have a spherical shape at the end. So this is spherical shape can be simply cleaned by using the G02, where the I and the J is going to be this one. Or simply I can use this radius, which is going to be 56 or 57, and the machine will make the cut for you. Just simply write down G02, define the end point, and the cutting tool will remove all the steps until we are going to reach that point. Of course, the same process will be repeated on that side. Actually, on this side, we can do the cut directly because I don't think there will be too much material. So the cutting tool can move directly and remove it. And then we're going to have G01 and done. Okay, so now, again, if I would like to find the coordination of each point, I click on that. It's going to give me the value for the X, the value for the Z. Remember that the value for the X you are going to have here, you have to multiply by 2 because the cutting tool understands that this movement is going to create a diameter, not a radius. If I'm going to give 17.4, the cut is going to be to half of the distance, not the actual height. It's going to be starting from here. So you have to be careful about that point. The problem is I don't know why I always forget to include the turning in the assignment. But well, I think I just made it once for the CAD CAM for the same part actually, and the student actually worked on that. We actually went to the lab and we cut the part by using the CNC machine. That was something about 2 years ago. Yeah, just before the COVID. We did that for 2 semesters. Then we had the lockdown, unfortunately, and it's all gone. I hope that, and we cross finger to be happen, that by the week number 5, we're going to have a session on the lab for demonstration of your CNC machine. And I hope we will be able to go. And then you can take your code from the assignment, put it on the machine, and cut the part by using the form. And then you can take this one with you to home and as memory from the advanced manufacturing. Yep. Okay. Now, do you have any question on how to use the solver? Well, I know it's longer process, but the same process, if you're going to do it by hand, is going to take even 5 times longer. So do you have any question about how to find the location of the points by using the SolidWorks?
Hey, so how similar is CNC so G code in the lathe compared to a mill?
That's the lathe. This
Is
one
the
is called
code
the lathe.
similar?
No. In the lathe, we don't have offset. Okay, the cutting tool is going to be exactly on the points where, again, the tip of the cutting tool will be exactly on the location where again to cut. Unless if again to have the rounded tip cutting tool like the carbide insert, the diameter is going to something about, the radius is going to be something about 1 millimeter. So you only going to insert that to the machine, and it's going to do the offset by itself. Just push it a little bit up, because we in the single tip, in the sharp tip, the end is going to be the location of the cutting. In the rounded tip, like the carbide insert, we're going to have the radius, and out of this radius, we're going to have the cut. So we always need to offset this location, which is going to be 0.5 millimeter. Usually it's not going to be a big difference. For the difference between the milling and the turning operation, or the lathe and the milling operation, that in the milling, you can go directly to a deeper level. You can go up to 4 millimeter, for example. You can do this cut. In the turning operation, because the part is going to be turning and we have a single point cutting tool, we cannot insert it too much inside the work part because it's going to have too much forces that break it. We have some certain calculation about the tool life and the depth of the cut and the forces exerted on the work part and the cutting tool. We need to learn on how to do the calculation for this one. Usually, I prefer this to be taught in the manufacturing process, not in the advanced manufacturing. But however, I'll try to give you some hints about it. I'll try to get the lecture from Western Sydney Uni recording and send you the link in the advanced manufacturing or here, so you will understand why we cannot insert the cutting tool too deep inside the work part during the lathe operation, while we can do that on the milling operation, though it's not recommended. Now, I don't need to have this sketch. I will discard this one, and we're going to teach you the last activity we're going to have for this course, which is going to be the CAD/CAM for this shape. This shape was the part we used to do in the CAD/CAM assignment in the advanced manufacturing till last year. This year, I replaced the thing. It seems to be simple, but it's actually the most complicated thing because we have a spherical shape at the top. The shape I saw you last time was quite simple because it was flat. So you can find the location of the datum point directly by clicking on the highest level we have for that point. Here, you cannot do that. So you're going to do another arrangement. Take a look to the shape. What we have is a long, what they call it, oval shape, spherical shape at one side, 6 cubes. and 6 holes. And of course, this level is lower than the top level by, I think, 5 millimeters. That's what we can see in the engineering drawings. So the first thing I'm going to do is I'm going to share the engineering drawing with you, and we're going to I'm going to actually work on this one. Do I have the engineering drawing on this one? Part 1. I think this was the one I opened. Yep. So I'm going to share this one with you guys, and you can try it later when you have time. Okay, now how to do that? I usually do the work with 2 screens. Okay, it's uploading now. Okay, now you have it. And again, I'm going to sketch that part by using the SolidWorks. So let's analyze the shape. What we have is this oval shape, and the diameter, the dimensions we have for it are from here to here is 150. It should be plus B. I'm not going to consider that. The diameter here is going to be 60. And the inner one is going to be 50. That means that the offset is going to be equal to 10 millimeters. So let's start with this one first. The total height is 15, and I'm going to consider this one as well. So let's go to the SolidWorks and start to make the new part. The plane I'm going to use for my sketching is going to be the front, because I need the XY plane. Do the sketch. And if I'm going to take a look here, this will be the part I'm going to start with, straight slot. I'm going to choose this center to be the left center. I'll go to it to be the 0, 0. So it's not going to be my datum point, but this will be very useful in my calculation. So this side meant to be 150. So I'm going to make it randomly to 150. Then I'm going to fix it myself. And the distance from here to here should be equal to 60. I can always fix that from here to do the following. This one, the height is 120 exactly. And the distance from center to center is 150 millimeters. So I have the shape now. That was easy, right? Shall I go to the next step? Shall I go to the next step? Is that easy to make this part?
Yes, sir.
Yeah, it's just a slot. And actually, when you click on it, you can change the parameters. Now, the other feature is I'm going to extrude that to 20 millimeter. Just remember, this is not going to be my the startup part. The startup part, again, is going to be a square shape, and that's what I'm going to show you at the end. Now we had that shape. Let's take a look to the drawing again. So in the drawing, what we are getting, let's take a look at this one. We're going to have the level will go down here by 5 millimeter. So I'm going to do that. I will cut to the inside. We said that the radius, the inner radius, is 10 millimeter smaller than the outer one. That means that the thickness of that wall is 10. Again, the easiest way to do that is click on the face, sketch, and do the offset of the intensities. It's 10 already. Reverse it and say OK. And then I get to the feature, cut extrude to, was it 5 or 10? Just give me 1 second to check that. It's 5 millimeter by 5. So go down by 5. Okay, so I had the boat shape. Now, let's make more analysis about the part. I'm going to have a circle here, which is going to be a spherical shape. And I'm going to have this squares. I'm going to start with this one. Because the center of that shape, or the base of the dome, is going to be the left center. And the midpoint of the first square is going to be the right center. So I'm going to start with this one first. I'm going to click on the middle here and do the sketch. I'm going to bring a circle, and I'm going to make my circle at this point, because this one is the easiest one to be found. Okay, so I'm going to take that to the, I think it was 25. So I'm going to take the radius to 25 and say OK. Then I'm going to offset it by 5 millimeters. I'm doing that on purpose because it's going to be very hard to start the dome form here and then cut it to this direction. I'm going to explain this one to you later. Now I would like to make a spherical shape at the top here. So I'm going to click on that face. I'm going to sketch, do the convert of the intensities. I made a circle, bring a line starting from this end to this end. Oh, sorry, someone is calling me. Just give me one minute. Sorry for that. Yep. So we made a line in the middle. Again, to finish with this one, escape. Okay. Now again, to remove half of this circle. So it's from entities, remove half of the circle, say OK. Now I'm going to choose this line and again to revolve this half of the circle around it. Now I'm doing that because we're going to have something similar to the in our assignment. We're going to have a circle, and we're going to have a socket, which is going to be the inside circle in our assignment. Now, just remember that this will be 360 degree, revolve around the line number 1. If I get to take a look to the other side, I can see that this one is still here. So I'm going to change that to 180 degree. Okay. If under any circumstances you are going to have it like that, that means you remove the other top. So just simply click on change the direction. Say, OK, I have the dome shape now has been created. Now I'm going to sketch the squares and the circles. So take a look to the engineering drawings again, and let's try to find some information about the work. Now you can see that the line of the first circle is 50 millimeter from the center of the dome. And the distance is 30 millimeter. So I can make one, then I can simply increase the number. For this one, I'm going to work from this side. So let's work on the squares first. Then we're going to go back and do it with the circles, which is going to be holes. So click on that face again. I'm going to sketch, and I need to sketch something on this direction. So let's try to find, can I find the, yeah, I can find the center here. So I'm going to make a line, and this line is going to be midpoint line. And I can find this point here, as I mentioned. Well, it's too tricky. So I'm going to make construction line first. For construction, it's going to start from here, ending to here at 150. Oh, no. I think that the easiest way to do it is construction line and just link between. What's happened to my mouse? Yeah. Click between this point And now you can see that now is appearing. That's so mean from the software. Anyway, so I did this line, and I'm going to use this line to make my first square. That is going to have the side length is 20 millimeter. Again, maybe this is a retarded way to do that, but I will keep using it because sort of I like it. And I'll go to the midpoint, and I will go to midpoint of the square. And you can see that I'm making a line from both directions. I'm going to make it at this location, and I'm going to change the length to be 20, and done. Now, the other line I'm going to make is going to be straight line, and this will be go to 20, choose 20, go to 20, and go to 20. So I just made my first square. Now, I don't need actually to sketch all the squares manually. I can simply replicate that by selecting this one and go to the linear sketch pattern. And you can see that I generated a square on the other direction. I'm going to move it to on here, and I'm going to push it to the side. I make it from one side. I'm going to take it to the Y direction, to the X direction in that case, and simply by adding another number here, and push this one up by 30 again. Say OK, and then I'm going to select these two, and I think I selected more than what I need. Yep, and I'm going to do it once again, the linear. I'm not going to do it for the X, so I'm going to take this one to 0 for the Y. I'm going to increase that. I'm going to reverse direction and send them to 30 millimeters and say OK. So I just sketched the 6 squares, and I'm going to take them to be a bottom to the top. So I'm going to, I'm not going to do the circles because just remember, one of them is going to be extrude up, the other one is going to be extrude cut. So extrude this one up, I take it by 10. Say OK. So I made the square bottom to this side. Now I'm going to make the holes before I'm going to work on the machining process. So again, I'm going to sketch. I'm going to do the construction line. We said it's going to be 50 horizontally. And then 30 down. Okay, now this will be the center of my first circle. This one, the diameter is 20 millimeter. So I'm going to sketch one, and then I'm going to do the pattern to increase it to 6 holes. Okay, so bring the circle. The radius is 10. Okay, and then I'm going to select the circle. It's selected already. Do the linear pattern. I'm going to push this one to the side. We said that the distance from center to center is 30. I will take it up to the Y direction, 2, and then I'm going to increase the center to center area to 30. Click OK. I had now the 6 holes. Features, extrude cut, make it through all, and say OK. Now we had the part ready. Maybe I was fast. If you have any question, I can repeat everything for you. I think it's just a basic thing, but it's quite to make some trick to make the thing faster. But the steps, most of the steps we done were basic steps. You can have the engineering drawings. You can have the video. You can pause it whenever you want if you would like to check any certain steps. And if you have any problem, just come back to me. Now I'm going to save this part. I'm going to call it the CAD-CAM example 2, CAD-CAM. Two. And I'm going to start to do the solid cam on it. Just remember once again, if you still don't have the solid cam buttons, you can go to the add ins, and then you can click on the solid cam, make it both, select both. So it's going to start up and it's going to be available for you. Now, what's happened to me, I had a problem last week for a reason or another, I don't know why. Anyway, the steps is going to be first new, do a milling operation. Now, definitely this will be milling operation because we're going to have the material going to be first a cubic shape. We're going to remove it until we're going to have the whole part generated. For the dimension of the cutting tool, I will tell you how we are going to choose it. And actually, we're going to need multiple tools. I can choose tools for cleaning the material, tools for do the spherical shape, tools for the drilling. Anyway, it's going to be milling. And it's going to start the steps of loading the part to the solid cam. Again, I'm going to leave it as external because usually if you're going to have it as internal, it's going to be built in inside the SolidWorks part. And that's mean you cannot use the part again because you're going to have a built-in solid cam code inside. External, say yes. I thought we closed this one. It's coming now. Okay, so as you can see, it's working on the plane X, Y, and the Z is going to be the height. I'm going to choose the machine. I will use the FANOC because I like it. And I'm going to start with the stock. In the stock, you're going to click on the part and it's going to be built the actual stock material around it. For me, I'm going to lower the material from the top to be, from the end to be equal to 0, because I just want to work on in one setup, not two. Okay, you can see this one has went in. Actually, it's going to be nice to do some profile cutting for that. So I'm going to leave the material from the sides. Material from the top, I think is 2 millimeter higher. It doesn't matter. I'm going to leave this one as 2 millimeter higher. And I'm going to work on that. This will be my stock material. Now, the coordination system, how to find the datum point. Now, in the datum point here, if I'm going to click on select surface, it's going to give me an error. Okay, if I'm going to click this surface, it's going to be wrong because the height, the 0 is going to be here. It's not going to be above this one. So I think that the best thing is to do it is to define the location of the datum point. Okay, and we can choose the value for that by entering the XYZ here. So let's see if I'm going to click on the top here, what would happen. Okay, you can see that it's give you here minus 2.322 for the X. For the Y is 0.18, and for the Z is 44.891. Now, the value we're talking here was actually selected from the origin point, which was here at the bottom. But I need to push the datum point to be on the side here. So I will try to figure out. Take a look for the part. From here to here is 60. And from here to here is 60. So I'm going to choose that to -60. -60, yep, -60. And for the X, for the Y, sorry, is going to be 60. No, it's going to be 60.
Y 0.
Yeah, sorry, 62. 62. Oh no, I got to take it to 60. Sorry, what what was your question? Sorry.
I thought Y was 0. Don't worry. It's
Oh
a
no,
mistake.
no. We tried to put it here. Got
Oh
that?
yeah, of course.
Yeah,
It makes
yeah,
sense.
yep. And now for the height, let's calculate the height. And now for the height, it says it's 44.89. Let's check that on the engineering drawings. What we have here is from here to here is 10. And then we have 25. I always choose this that is 44. It should be higher. Oh, sorry, yeah. Yeah, we have 45. So it's 45 because we have 15 to the base. Okay, 15 to the base here, then 25, and this will make it 40. Why is 40? Why is 40? Why here is 45? Anyway, I will choose as 45. I don't know. I actually confused with this one. Okay, now let's give me wrong readings because I think the X, Y, and Z -60. Oh, -60, -60. Okay, so I don't want it to be here. Okay. I will choose another trick. Just end that, I don't need that. Close that, and I'm going to choose the coordinator again. I'll try another trick by I'll select surface. I will choose this one. Okay. Well, it's done by itself. Yeah. Yep. Well, actually, I think they updated the software because before that, we needed to define the maximum height manually. Anyway, yeah, it's done now. So we have the X, Y, and the Z datum point has been defined. That's okay. Thanks God. Things became easier for me this time. Okay, so now we finishing the steps. Everything is being defined. And then we go to the machining steps of the part. Now we can have some templates here, but I'm not going to use it. Instead of that, I'm going to do it myself. So I'm going to hide this side by clicking in the middle here. And the first thing I need to do is I need to select the tools. To select the tools, we need to pass the tool form here between these cubes. Distance from this line to that line is 10 millimeters. I'm going to choose the cutting tool to be 8, flathead. I'm going to do drilling for these holes, 20 millimeters. I'm going to choose the cutting tool of 20. I thought this would be too much. Anyway, 20 to do the drilling for these holes. This tool cutting tool. I just want to increase the number of the tools. And we're going to have the cutting for the dome shape. Dome shape cannot use the flathead. It should be either nose ball or the lollipop. I will try either of them. So let's make a library for my tool. First tool, again to add is an end mill. I will choose the 8 millimeter diameter. Tool number 1. Tool number 2, I'm going to use the end mill, not the drilling tip. Okay, not the drilling tip because the end mill, the flat one, is going to do the drilling flat at the end. So it's not going to draw the table of my milling machine. I will choose the diameter to be 20. Okay, I know this may be going to be quite large, but at the end it will do the job. Now the third tool I'm going to use, I tried the Lollipop. I hadn't tried the Lollipop for a while. The Lollipop can cut the spherical shape or the contour shapes. Diameter is 10, again to make it to, and I will make it 5. Okay, I know it's going to be quite small. And the arbor diameter is going to be 6, that's okay. And I'm going to use this one as my third tool, save and exit. And cutting length is not in range. For what? Okay, it was 10 before.
Maybe it's a minimum 6.
No, that's for the arbor here, but we're talking about this one. Let's see what will happen now. Yeah, it's accepted as 10. Anyway, I'll try 10. If it didn't work, I will use the other cutting tool here, which is going to be the ball nose mill cutting tool. And I'm going to choose this one to be as small as possible. So I'm going to use it to be 4 millimeters. Okay, and I'm going to choose this one as a spare if my ball nose not going to, the Lollipop not going to do the job. Okay, I have now everything ready. I'm going to start to do the operations. So I'm going to go to the setup, right click, and I'm going to insert, add a milling operation. And the first operation I'm going to do is remove the material around the part from the top to cut the shape. I will leave the cutting around the part to make it as the oval shape or the slot shape at the end, because we're now holding the part from the side, so I cannot cut around it at this moment. So I'm going to cut once again to the top, and then I will come back to the other operation. So add milling operation, I'm going to do 3D milling, and I'm going to choose the geometry first. So go to the define on the work area, and the working area, define. So I'm not going to cut the circle. So I'm going to click on this line. Okay, so I'm going to leave a cylinder at the beginning. Again, not going to cut the square shape at the beginning. So I'm going to choose them. Shall I? No, I'm going to leave this one. I'm going to leave that. Chain 2 and chain 3. Delete. Yes. Yes. Okay, so we got this one first. I'm going to choose this one. Yes. And I'm going to cut between that and this one. Yeah. So this will be good. Okay. And I will say, okay, the tool. I'm going to select the larger tool, the 20 millimeter diameter. Just remove the material at higher rate. Say okay. Now, it's very important thing is about the level. The upper level is going to be equal to 2, because we have 2 millimeter at the top. Now, the lower level is going to be important. I don't want to have these things to be cut till this end, because this will remove these square shapes. So again, to choose, this will be my upper level. It's minus 19.99 or 20. Technology I'm going to use for that. For the rough, I'm going to use the contour. It's going to do the work around, or I can use the hedge. It doesn't matter actually, the hedge or the thing. The most important thing that is what will do the work. I can use the contour. Okay, and I say save and exit. Upper level is above coordination system. But it's not. How is it going to be above? Oh, yeah. Because we have 2 millimeter above the material need to be removed. Okay, so we are going to do the calculation for this one, just to see what will be tool path to remove the material. So what you can see here that we are going to cut to the top level of the square, the cubic shapes. It's going to leave the circle shape by itself. So I'm going to cut it now. Now, the next step, I'm going to unshow these lines. I'm going to cut to that level. So it's going to show up the square shapes. So I'm going to add an extra operation setup. And of course, in that case, I'm going to use a smaller cutting tool to do the work because I need the cutting tool to pass through the squares without breaking it. 3D milling. I'm going to define the geometry. To define the working area. So the working area is going to be around these cubes and within this square shape. So now the cutting tool will move between these parts. Oh, I need to define that again. I need to have the edge here. Okay. Now everything outside the purple lines of the squares and the circle and between the outside one is going to be cleaned. But actually, I'm going to remove this one because I think we can simply clean to the outside because that's what we need. This will take the level lower, and this will be much easier for me to do the work later because the whole level will be done. So now everything outside this square should be done. I hope it's going to work because sometimes it doesn't. Okay, choose the tool, select. I'm going to choose the small diameter one, the 8. Say OK. The levels. Now the upper level is, we cut it to that height. The lower level is going to be the side here. Say OK. The technology we are going to use is going to be the contour because we are going to have multiple turning around the part. Do the calculation for that. And just cut around this one. I had cut the rest of the material. Did we use the cycle? We use the circle here.
So could we remove the first one?
Sorry?
Could we remove the first operation?
No, I hadn't moved in the first operation. I'm sure about this one. Now, if I'm going to show you the rest of the material by this simulation, that's what we're going to have. Take a look on this one. Okay, so if I'm going to do the simulate and try to show I hope it's going to show up the material machine, press material. It didn't work. Oh, I don't want to have this one. I knew this will happen. Now it's going to start. Oh, it's still here. Come on. Stop working. A simple mistake. Did I save the work part? Yes, I did. So I think I need to restart my program again. Just give me 1 second. Okay, do we have SolidWork here? It's the second one, I think. Okay, just give me 1 second. I need to start updating again. That's why I always ask a student to save when you do the work, because that's the mood of the SolidWork. Stop working immediately. It's too moody.
Why are you using 2020, sir?
What? Well, it is 2020.
Yeah. Oh, I thought you had 2019 installed in your computer.
No, that was the old one when I used to have the VMware. Yeah, actually, I had the chance. Yeah, I had the chance to download the SolidWork from the university, but the problem is that if I get to download it, I don't have the license of the SolidCam. And in that case, I'm going to use the demo one, and the demo one usually is going to work for 1 month only, and you cannot generate the G code with it. Before we bought,
Okay, that makes sense.
Before we bought the SolidCam license in 2018, actually it was too hard. I've been asking the school for many years to have that, until that Ben Holken became, by coincidence, the subject coordinator for the advanced manufacturing, and I was working with him as the active subject coordinator. So I asked him to purchase the license, and we got it, and we still have it. Luckily, that it was. We still have the 2018, but in all the cases, it's still working, and that's the whole thing. We don't need anything more. Come on, work.
Do you know how to use Fusion 360? Have you used it before?
Fusion 360. I think I used it before, but this was a long time ago.
Because I want to get into generative design.
Have you found some examples on that online?
About what?
The Fusion 360.
If I wanted to learn it, I'd just go LinkedIn Learning.
Uh-huh. No, I think you can find manuals somewhere that can show you step by step PDF file, and try to do it
Or
yourself
perhaps
first.
it has tutorials inside, like SolidWorks.
Oh yeah, I think it does. I think it does. Yeah. Okay, now it seems that the software doesn't work. Maybe I need to close that and come back again. That's the funny thing with the VMware. Back in the old days, when the your apps only start being refreshed yet, when we didn't have the i7 memories, processor, and the other things, I got a laptop. I installed the SolidWorks on it, and I tried to do the SolidWorks fluid simulation. And still, sorry.
Yeah, that's terrible in SolidWorks. Just always get answers.
Yeah, I think that the best way to do that is try to log it off from here. It's happened to me earlier. So we go to the workspace, we go to connection center, and we go to SolidWorks. Should give us an option to terminate. Say yes.
Normally, what I do is I'd exit Citrix.
Yeah. Well, I tried to do that. It didn't work. So I don't say this one, and I will try it again. Now it should be terminated. Just terminate. Come on. Terminate.
From Task Manager, close all Citrix windows, not just that one.
So you have to do it that way. Okay, now let me try. Maybe it's going to work right now. Yeah, it's working.
Hey.
Yeah. I learned this trick because what's happening at the beginning, that when you start the thing at the for the first time, it's going to ask you to log to your SkyDrive, they call it now SkyDrive, whatever the name is.
OneDrive.
Yeah, OneDrive now. Because back in the old days, it's just called SkyDrive or SkyDrive. I think it's from another website. I don't remember. But I missed that. I missed that by mistake. It took me to the Internet Explorer and didn't work. And after that, I had to find my way like that, terminate the thing, and when or log off, and when I start the software once again, I went to the correct direction and log it to the OneDrive right now. Okay, so once again, I need to start doing that, do the milling operation, and I'll go through all the steps. Yeah, as I tell you that I tried to do the fluid simulation using my own laptop back in 2014, I think, or 13. And because I was watching these tutorials and they were doing the thing just like that. I tried it on my computer. It took me a whole week to finish the simulation, a whole week
For the fluid dynamics?
for the fluid dynamics. Yeah, at that time. Yeah, in all the cases, I made one publication using their fluid dynamics, and then I went to the INSIS because the university can give you something working on the cloud for the simulation, and it's much, much faster, something like a supercomputer. It's worked for a while very good in the clusters, but then suddenly it start to hang on and keep you log in, and the university send you an emails, try to log off. You tell them, oh, it's not responding, and they don't believe in you. And you ask them to reset the thing. They tell you it's very simple steps. Just do 1, 2, and 3. Tell them I tried everything. It doesn't work. Yep. Anyway, I still don't understand how those people who making these videos, maybe they pose it, maybe they do something else, but when they do the simulation, everything happening too fast. Okay, so once again, we're going to add the milling operation we did earlier, 3D milling. Oh, I need to define my tools yet first. Bar tools. Sorry for repeating that again. Okay, so it's going to be the 8. Save. Number 2, 20. Save. Number 3. The bull nose. 5. Okay, save. Number 4. It's going to be the lollipop. Other thing we have actually on the solid cam, which is what we call the prop operation. We're going to explain that to you, and again, you need to find. I will show you some examples later, but you need to find your way on how to use it to do some measurement checking, like this one, the prop operation, during the metrology lab we have. Okay, 3D milling operation, and I get to go through this one fast because we already knew how to do it. Define the working area, and the working area is going to be everything between here and here. Okay, and we go to the next step, choosing the tool, 20 millimeter. Choosing the level, upper level is going to be set 2. It's going to be above the work a little bit, and the lower level is going to be to the sequence. Okay, the technology is going to be the counter, and save and exit. Yes. Okay, I will add the second operation directly. Add the milling operation, 3D milling, and define geometry, working area, define this one. Okay. Okay, and the outer ring, say okay. Okay, and then the tool is going to be the small one because we wanted to pass it through the cubes. Say okay. The levels we are going to choose is the upper level is going to be this height, and the lower level we are going to have is going to be to the wall. So this will remove 5mm diameter. Technology is going to be the counter, and say save and exit. Now the calculation I hope is going to do, yeah. So it's removed the material, okay, to the height of the wall, saving the cylinder here in the middle and the cubes. Now the third step is I'm going to remove everything inside this one to make the shape. So I'm going to add another operation, that, right click, add a milling operation, do a 3D milling again. And in that case, the definition of the working area is going to be very simple. Just define that and click on the base. Okay, so now everything around the cubes and around the circles to that level will be cutted in this operation. Say this.
Could you do broaching?
Sorry?
Could you do broaching to make the squares more square?
I think we can, yeah. Well, let's see what will be the final shape we're going to have here. 2 is going to be the small one again, and the levels, the upper level. Now we cut it to this height, so this will be the upper level, and the lower level is going to be this one. Okay, and then the technology is going to be the contour because we have a cylinder in the middle. Okay, now let's see what will be the square shape you're talking about. Okay, so it's made it rounded. Yeah, you're right. It's going to be rounded. I don't know why. I'm passing it twice. Yeah, actually, in this case, we may have. Okay, I'll try to do something here. Just let me give something. So for the tool, select. Again, to add another tool is going to have 10mm diameter. 10, because that's actually the actual distance we have, 10. I hope it will work. I remember that once it hadn't worked. Okay, so save and exit. Let's see if it's going to work. Oh no, now you can see it's misted. I didn't clean the whole area. Okay, now let's try to modify the tool. Go into tools, Hard Tool Stable, number 5. Change that to 9. And let's see if it's going to work. Save and exit. Yes. Calculate. No, it didn't pass. So it must be the 8. It must be the 8. Okay, so edit this one. Change the tool to the 8mm. I'll try to find out why we are going to have this rounded shape at the end. Well, when I actually apply it wasn't rounded shape. I don't know. I will need to investigate that. Okay, now the other operation we're going to do is before we're going to drill the holes. Oh yeah, I'm going to drill the holes first, then I'm going to do this one because this one is going to take forever. So let's add another operation, and this will be a drilling. And go to drilling operation. and I'm going to select the drill holes. So basically, if I'm going to click on the lower side, lower rings, this will be the holes. You can see that all is going to go in the clockwise direction instead of jumping from one point to another. And this will make it easier for the machine to follow the steps. The tool is going to be 20 millimeter diameter again. Say OK. And the level.
What does center drill mean, sir?
Sorry?
Before it says center drill.
Yeah, center drill. Have you seen the points here has been defined? I'm sorry. When we selected, have you seen the purple point in the middle?
Yeah.
Yep, this will be the center of the drilling we are going to have. Now for the level, drill depth is going to be, check this one, minus 45, say OK. Technology, we are going to have adjusted drilling. We don't need to do anything else. And we need to save and exit. And this will be drilling operation. So what you can see in the drilling, we're only going to have, I think there's something wrong with this one. Why it doesn't show me the calculate? If it cannot show you the calculate, that means there's something wrong with that. So let's try to calculate all and see if this one is going to be done. Say yes. Oh yes, it's done the drilling. You can see that we have this multiple movement for the cutting tool to perform the drilling operations. 6 lines going downward, 1, 2, 3, and this will make the hole drillings. Okay, now the last thing we're going to do is going to be actually the most annoying one, because it's going to take forever, is going to be the drilling, the cutting of the spherical shape. Set up, and I'm going to add a milling operation. Now let's take a look for this one. What do we have? We have contour in 3D. Let's try this one. Contour 3D, select the part. So again, click on this surface. So did it work? No, it hadn't worked. So again, to click on that. Say OK. Okay. And I'm going to choose the tool. It's going to be the, I'll try the Lollipop for the first time for a while. The levels, the upper level is going to be 2. The lower level is minus 25. Okay, technology center. Yeah, just leave it to the center. Center, just give me 1 second. Right. Let's try that. Save and exit. The machining operation defined. No matching operation. Why? Okay, let's leave it to the center and try. Okay, now we are going to do the calculate. Definitely it didn't work. Okay, let's do this one separately. Simulate. Now I just got it from the bottom. So I'm going to edit this one. If it didn't work, then I'll try to change it at all. Tool, the geometry, define geometry. X, Y, yeah, we choose this one. Yeah. I'll try to do it the other way. Okay, so I'm going to delete this one and make a new one instead. Delete, yes. And I'll try to add a much easier operation. Okay, now we have the contour, debugger, drilling, thread, slot, slot, triangle, toolbox, engraving. I'll go 3D milling just to see what will happen. Okay, 3D milling. I will define that, and I will define the surface of the working area. I hope it's going to work. Nope, it didn't. Okay, so let's go to the selected faces, define. Yep, I think it's worth. Okay, now the working area. It's okay to be defined to be this one. Okay, so we define both. And let's see if it's going to work. The tool. Again, I'm going to choose the Lollipop. Hopefully it's going to work this time. The levels, it's going to be 1. And minus 25. The technology content. And save and exit. Yes. Calculate. Okay, so that will be the movement we're going to have for the cutting tool to perform the cut at the end.
Just to see how the lollipop works, can you simulate that?
Yeah, I'll try to simulate that. You can see that the lines we are going to have here is going to be too much. So let's try to simulate that. See what will happen. Well, definitely what I can see here, it hadn't cut this area. So we'll try to play with that. Anyway, let's try to put in 3 dimensions. Stop. I think that's the step was cleaning the thing. Anyway, I still don't understand why it cannot show up the rest of the. Yeah. So you can see that this will be the material that left it after we do the work. Definitely, we're going to do less operation by do the profile cutting around to have the oval shape. But you can see this will be the shape we're going to have now for the dome, which is not correct. So what I'm going to try to do is modify that. And we can do that by doing, I think, for the levels, clearance level, safety distance, no. For the technology, the overlap is 0.5 millimeter. The offset is 0.05. So I'm going to reduce that to be 0.25 first. And the delta, the offset, the clean sheet, semi-finished. It's going to be spiral. And the wall offset is 0. It's okay. Let's try to do this one first. I think that we can decide what will be the levels we are going to have. So clearance level is 25. I'll try to reduce this one to 5. And let's try to check this one. Yep. Okay, and I'm going to give it another try, which is calculate. Now the line should be more dense now. Okay. Now you can see that we have some green lines, and why is happening only for one side? Should be done for this side as well. Anyway, let's give it a try. So you do the simulate. Let's check as the rest of the material. Do the calculation now. Now you can see that that's funny, right? That I have this one is cleaned, but still have it on this area. Let's try to find out what's happened. Click here. So it's doing the right thing now. It's nice, but I still don't understand why it hadn't do it for the other side. We'll try to check what's happened here. Look, it's stopping here and go back to the end. Should be from end to end.
When you set the two settings, did you put it on left, right, or center?
I left. Well, this one doesn't have center or left and right as far as I remember. Anyway, we'll check that again. So again, to stop that and go back to the editing, and let's see what's happened here. Why it's stopping at this edge and not go back. Okay, so the first thing was the clearance level was 5, and this was good. And we got the technology. I think we played on that. So spiral, plunging. Steps, no. Okay. So what we changed here was we selected that spiral, all offset 0. Try to do another thing. Circle pockets not. No. Pencil milling, constant step. I'm sure that this spiral should be the one, because that's what's happened with the finish cutting. Anyway, let's try the what's the offset cutting? No. No circle pockets for the inside. Linear is a line. So I'm sure that is spiral is correct one. It was going around doing the work until we finished everything. The only problem I have is why it didn't finish till the end. So let's go to geometry, try to define that again. Okay, so 3D geometry is, oh, no. No 3D, let's go with this one, fine. Okay, so what we have here is check faces, this one. Okay, we choose that face. Okay, face 1. Work on the select faces. That's what's happened actually. We don't have any problem with that. I'll try to do something here. I will try to remove this one. Maybe this was the problem. So again, to untick this one and give it a try. Okay, now let's do the calculation. Oh no, calculation happened. That's mean we had a problem here. Anyway, simulate. Oh no, so we went back to the same thing. Okay, again, edit. Define. Take the working area. Define the working area. I'm going to select, drag again, say okay, The tool working area is going to be external, of course. Internal, tangential to, let's try that. Work on selected faces, we did that. Check faces, did that. Okay. Tool was selected, the level was selected. The clearance level was 5. Let's reduce that to milling levels 25. Let's do that as 2. Okay. Technology may have something in advance. No, I'm not going to play with this one now. The finishing was done already. The finish is spiral again. The fillet size should be okay. Save and exit. Give it the last try. I couldn't make it right now, then I will leave it to you. Now we had a problem here. Now it's not calculating. No. Usually, if you're going to face similar problem that the thing is not calculating, and you tried multiple times to edit it and didn't work, so simply just delete it and do it again. That's what I usually prefer to do. So again, to remove that, I don't need it now because it seems that doesn't work. It's fine. Again, to remove that face because actually it's all started when we did this one. Yeah, it was correct actually. Set is the 2.5. No, actually that's made the problem. Okay, faces. Okay. And let's try to do it again. Save and exit. Yes. Okay, now again, I still don't understand why it doesn't simulate.
So I reckon just change the cutting tool. I don't think Lollipop is a good idea.
Yeah, I think the best thing is again to delete it and do it again. So again to delete that.
Use the bull nose or something.
Yeah, yeah. I will do that. Okay, now so once again to add a new operation. And that's going to be, I'm not going to choose the, well, actually it should be the contour 3D, by the way. That should be the process. But I still don't understand why it hadn't worked. Okay, let's try to do the contour 3D and using the ball nose instead. And define that. And we add a face instead of the contour. Anyway, set this one. Say yes. Now it should be within this area. Say okay. And the tool, I'll use the the ball nose 3, I think. Yep. And the levels, the top level is 1 minus 25. 25. Clearance level is safety distance is 2. Contour depth. Contour depth. Okay. Technology is, I'll leave it as center. The offset to reference is going to be the tip. Semi-finish step down is 1. We'll finish. Let's see if it's going to work. Actually, it's only going to cut around. I don't think this was correcting. That's why I always prefer to use the 3D milling. So let's see what's happening with the rest of the material. Yeah, the funny thing that it's cleaned everything to the side here. Then it's left the tab one. So I'm not going to stay with that forever. So I know that you need to do something else, which is going to be more important than this one. So step down. Let's see, you finished. This one to 3. And I will try to go to something we did here. Clearance level is 5. Yeah, I'll give this one as 25. Safety distance is 1. Contour depth is yeah, I got that. Is equal to 25. I'll start to do as 15 and check what will be the difference for this one, because I think that's what made the change. That's why it's just the lower part. Yes. Simulate. Rest of the material. No, still the same thing. I remember there was some.
Machining?
Sorry? Sorry, I didn't get that. Can you repeat that?
I think there's a milling operation called constant Z machining.
Yep, I think that's what's happened. But anyway, I will go to 3D milling directly, not the contour. And I hope it's going to do the work perfectly. Well, if not perfectly, it's going to be at least what we'd like it to be. Okay, so we go 3D milling. And we're going to do the work as usual, define. I'm going to define the face one time and say, okay, we're going to work on this face. The tool is going to be the number 2, 3. Okay. And the levels is going to be 0 and minus 25. Okay. The clearance level 25. Take this one to 5 now. And then we're going to go technology. We're going to use the contour. And then the overlap 0.5. Oh, yeah, yep, I just remember that. I'll take this one to 1. Okay, everything else is going to be the same. The overlap is going to be 0.1. Okay, and now let's see what will happen. Okay, so calculate. Oh yeah, that's how to make it dense. Yep. Yeah, I think it's going to work now. I think that the only thing we're going to have is going to be at the end, we're going to have a tip. And we are going to solve this problem by increase the height a little bit. So I made that working fast. Rest of the material will be like that. So we had the tip at the end. The offset of the work will make these rings smaller. If I'm going to take the work a little bit higher, it will start to cut this one as well. And that's what we're going to try. Sorry for that. Sorry for keeping you a long time. Yeah, but that's what I usually happen to me of having the trial and error process. So I'll put this one down to 0.5. This will take forever. And the offset is going to be 0.05. can I make this one overlap? Anyway, let's take this one. Okay, the wall offset. Floor offset. One. And everything else is going to remain the same. And oh yeah, the levels. Take the upper level to 3. Yes. And do the calculation. Now I'm doing that because we're going to have similar shape in the assignment. Now you can see that this should do the job. I know that simulation may take forever, so we can always make it faster. And play it now. So this will be the movement. It's going to be 2 dense, and of course, more dense, that means it's going to remove the material and get you the best surface finishing. Okay, now we got it. We got it. It's almost what we want. I think this will be the best quality you can have with the nose, the ball nose. I think the Lollipop, because it's going to have more circular shape and it's cut from the side, can take this one to a better cutting. So I will leave this one to this point, and I'll try it myself on how to use the Lollipop instead of the normal cutting tool. And I hope I will update you if it's going to work or not. I'll give it one try in front of you, then we can leave. Okay, and save and exit. Yes. Calculate. And give it simulation. Press all the material. Tell me something good. It's a little bit, just a little bit better for the Lollipop. We maybe need more work on that. Okay, so that's how to do the work. And I'm going to work on this one further. I'm going to go for the last step, which is going to be the counter cut for this work. So we're going to add another operation. The last thing is going to be add milling operation. I can now actually do the contour, not the contour, the profile cutting. Okay, and the profile cutting is going to be defined for that face. The ring at the bottom. Yep. Okay, and say okay. And finally, I'm going to choose the tool. I'm going to choose a 20mm diameter. Now we have the hole, so we can simply fix the part with the holes using the bolts and the nuts, and working on that. For the upper level is going to be, I'll take it from 0. I'll take it from 0. 0. And the lower level is going to be this one, which is minus 45. Technology we're going to have is going to be to the left is okay. Okay. And this will be okay. Save and exit. Make the calculation. So the cutting tool is only going to go around and do the work. Just let me try to do this. Simulate. I saw the material. Oh, it's got it the wrong way. So I need to change the direction from instead of the left, I'm going to take it to the right. So edit. And here we have the left and to the right. Compensate on the finisher passes. Depth of the cut. On. Save and exit. Yep. Now it's going to do the job. and this will be the simulation. Okay, and show the rest of the material. So we cut it around and we finish the job. So we got our part cut from the outside, and now it's ready to be done. So now we have everything. I can select all and do the simulate. And of course, it's going to show me all the operation steps by moving the cutting tool around step by step. Now, the sequence is very important. We cutting step layer by layer until we're going to finish the whole thing by sequence. So I hope this tutorial was quite useful for you. I told you that we are going to have a part which is going to be similar to this one in the assignment, but instead of having just the ball, we're going to have the ball and the socket on the other side. So actually the same process is going to be repeated, just use a 3D milling, and you're going to use one time the face at the top, the other one the face at the bottom. You saw that the steps and the overlap, if you're going to reduce this one, you're going to have a better result for the surface roughness of the shape. Okay, so I think that's it. We almost finished with this short course, and by having this experience for everyone, it's going to be much easier for you to work on the assignment, which is going to be due by the week number 4. We're going to start with it actually starting from next week. I'm going to release all the engineering drawings, and we're going to have some further discussion about it. And the other thing we're going to explain is how to record the sessions and how to write down the report and how to write down the engineering planning process using the Google Chrome, right? You're using the Google Chrome. If you hadn't, get it and try to get this extension. It's called the Numbers Screen Shoot and Screen Video Recorder app extension. It's free. It's almost free, but unless if you need to have more advanced things, then you need to do subscribe for that. You can do video recording for your screen, and you're going to use this one when you're going to do your video assignment for the assignment number 1. Okay, so I advise you strongly to get this extension for the Google Chrome. Okay, so I can stop recording now, and I hope that you got the benefit required from this course.